Hey mathematicians, and gear up, as today we are going to practice classifying different figures based on their properties. Let's get into it with our I will statements. Remember, your I will statements are your goals for this lesson. They are what we are trying to work on and learn more about throughout our time together today. As we continue on in our lesson, make sure you have your mind focused on these three things and showing them to your teacher. I will read the I will statement first, and then we will read it again a second time together. Make sure you're reading it nice and loudly so I can hear you, but no shouting necessary. Listen to me first. I will identify characteristics of different shapes. Read that one with me. I will identify characteristics of different shapes. Nice job. Let's look at the second one. I will measure and label angles. Say that one with me. I will measure and label angles. And our last job, mathematicians. I will compare shapes. Read that one with me. I will compare shapes. Good job, mathematicians. Give yourself a pat on the back and get ready for our warm-up activity today. For this activity, you're going to need your whiteboards and a marker. You don't need to draw the shape here, but we are going to use the formula for volume. So you'll want to write volume equals length times width times height. We're going to use that. And looking at this figure here, we need to visualize a line that breaks the figure into two different rectangles. Then we can find the volume of each of those rectangles and add them up together to find the entire volume of the rectangular prism. Let's start by breaking this cube up into specific parts. Let's pick it up. Let's start by doing 3 centimeters times 1 centimeter times 1 centimeter. We were to multiply 3 times 1, we would get 3 centimeters. Write that on your whiteboards now. Now, since we're breaking this up into two shapes, we also need to solve for our other shape. So we'll do 4 centimeters times 1 centimeter times 1 centimeter. And when we multiply all of these numbers together, 4 times 1 times 1, we're going to get 4 centimeters. Now that we have found out the volume of each of the figures, let's add them together to find out the total volume of our image. 3 plus 4 centimeters, 7 centimeters. But since we're talking volume, we have 7 cubic centimeters as our answer. You are going to continue on with another difficult shape. I will project the shape on the board, and it is your job to break it up and find the total volume of that shape. You may work with a partner, but you only get 2 minutes to solve. After you guys solve, you'll talk as a class comparing how you split up the shape and talking about if there were different approaches that got you to the same answer. Here's the shape you will use, mathematicians, in trying to solve volume with your partners. After you have had time to work on this activity, take a minute to stretch and then come back when you're ready to start with the new material for today. I'll see you guys in a second. All right, mathematicians, we are going to be talking about shapes today. For this first part, we're just going to look at some true and false statements. For the first statement, I'll write it on my whiteboards and we'll read it together as a class. We're going to first talk about trapezoids, and we're going to see if trapezoids are always quadrilaterals. So if you think this statement is true, I want you to stand up now. If you think this statement is false, I want you to stay seated. Pause the video and count how many people think the statement is true and how many people think the statement is false before coming back and working through the statement with me. This is a true statement. statement because all trapezoids have the same properties as quadrilateral. They just have an extra property. They have exactly one pair of parallel sides. If I were to draw a trapezoid now, a trapezoid is going to have two sides that never touch. They'll be parallel lines, but our opposite sides will intersect eventually. If you look at this trapezoid I drew, though, it has four segments in the same plane, and they all intersect at their endpoints. They all have hit their sides, and it has four individual sides, making it a quadrilateral. You cannot draw a trapezoid without these properties, the properties of a quadrilateral, but you just need to add that extra step that your trapezoid has that parallel sides. So a trapezoid is a quadrilateral. If you stood up for that, give yourself a high five. Let's look at another true or false statement together. Let's read this next statement together. This one says quadrilaterals are always trapezoids. It's our other sentence, but I flipped these two around now. Now, if we were to think, is this statement true or false? Let's do the same thing. Stand up if you think this statement is true, and sit down if you think this statement is false. Pause the video and tally up the score of how many people think it's true and how many people think it's false now. If we were to look at this trapezoid, or at this statement, this is not a true statement. There are a lot of quadrilaterals that do not have parallel sides. And if a quadrilateral does not have exactly one parallel side, it cannot be a trapezoid. In our beginning statement, when we flip these around, a trapezoid could be a quadrilateral because it had those four different sides. If we were looking at another example of a quadrilateral now, if I were to draw a rhombus on this side of my paper, this is still a quadrilateral. It has all four sides and they meet at their corner end points. But it's not a trapezoid. These sides will intersect. It doesn't have one perfect side of parallel like our trapezoid would need. When we are looking at different ways to qualify shapes, it's important that we pay attention to the exact characteristics that we are being asked to identify. On your whiteboards, we are going to write the following sentence. Erase your whiteboards if you have anything on them and write this with me. Blank are always blank. In this sentence frame, we can write different statements based off of the true or false statements that we looked at today. In this case, we found out that trapezoids, and you can write this in with me, are always quadrilaterals. Pause and write that in, and then let's read it together as a class. Read it with me now. Trapezoids are always quadrilaterals. And we know that because we looked at the specific properties of a quadrilateral and the specific properties of a trapezoid, and we saw how they aligned. But if we were to flip this sentence frame around, it wouldn't work because quadrilaterals are not always trapezoids. It's important that when we classify two-dimensional figures, we look at those specific properties and we confirm to see if it works. We drew out our trapezoid and identified all the things of a quadrilateral. But when drawing examples of quadrilaterals, we were able to spot some shapes that didn't have the same qualities of a trapezoid or that made up a trapezoid. You are going to continue to explore with your teacher different shapes and how to classify them based on their properties. You'll look at some comparisons and see what shapes fall into specific areas, and in some cases, which shapes can always represent specific categories. I'll see you soon, mathematicians.